Good afternoon, class. We are looking at analytic trigonometry, sum and difference formulas. Sum and difference formulas. So we looked at trigonometric equations and identities, and now sum and difference formulas with the following objectives. Use sum and difference formulas to find exact values, to establish identities. Use sum and difference formulas involving inverse trig functions, solve trigonometric equations, linear in sine and cosine. Again, because we are going to go with more identities, I remind you of the identities that we have seen, such as the fact that trigonometric functions are periodic, and the period for all of them is 2 pi for tangent, and therefore cotangent is pi. So you can say 2k pi or 2n pi, k is an integer. They are all odd functions except cosine, and with that goes secant. Pythagorean identities: sine squared plus cosine squared equals 1, tan squared plus 1 is secant squared, 1 plus cotangent squared plus cosecant squared. Quotient identities: tan theta is sine over cosine, cotangent is cosine over sine, and reciprocal identities: cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. Those are the identities we should be very comfortable with. So just making sure that we've seen them before. And now we are looking at new identities. Okay, everybody. And so here's the summary of this section. Sum and difference formulas. Sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Sine of alpha minus beta, basically if you change the beta to minus beta, this remains the same and this one becomes minus. So sine alpha cosine beta minus cosine alpha sine beta. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta, and cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. Tan of alpha plus beta is tan of alpha plus tan of beta over 1 minus tan alpha tan beta. Tan of alpha minus beta is tan alpha minus tan beta over 1 plus tan alpha tan beta. As you can see, there are more identities coming your way, everybody. So we are going to go with the proof, and we're going to start with cosine. And to do that, in fact, we're going to start with cosine of alpha minus beta by looking at the following two angles, alpha and beta. So this angle is beta. Therefore, this point has coordinates cosine beta sine beta. We call it point P1. This angle, the longer one, the larger angle is alpha. Alpha is larger than beta. And this angle is alpha. Therefore, this point has coordinates cosine alpha, sine alpha. If we move this such that P1 actually moves to this point, this angle, such as this angle, is alpha minus beta, and this distance is the same as this distance because it contains the same central angle, alpha minus beta. So this distance is equal to this distance. Distance of A to P sub 3 is equal to distance of P sub 1 to P sub 2. Now we are going to use the distance formula for each piece. For this one, Remember, x sub 2 minus x sub 1 quantity squared. So cosine beta minus cosine alpha, or cosine alpha minus cosine beta quantity squared, it makes no difference, plus y sub 2 minus y sub 1 quantity squared, plus sine alpha minus sine beta quantity squared under the radical. So that's the distance between P1 and P2. Now, what about this distance? Again, x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So cosine alpha minus beta minus 1 quantity squared plus sine of alpha minus beta minus 0 quantity squared under the radical. So this is the distance formula for the green piece, AP3, and this is for the yellow piece between P1 and P2. Now, in order to work with this, it's easier if we square both ones. So we are going to look at this one without the square root, the same thing without the square root, and these two are identical. Now, all we have to do is square them and see what happens. Let's start with this one. Cosine alpha minus cosine beta quantity squared. And I'm assuming everybody remembers a minus b quantity squared, a plus b quantity squared. So this is cosine squared minus 2 cosine alpha cosine beta plus cosine beta squared. This one, sine squared alpha minus 2 sine alpha cosine beta plus sine squared beta. So that's the left side. This one, you square this one, cosine squared of alpha minus beta minus 2 cosine of alpha minus beta plus 1. This one, this is 0, has no bearing, simply sine squared alpha minus beta. So I'm assuming you can square the left side, that this parentheses, and square the right side, this parentheses, and this one is just sine squared alpha minus beta. Now notice, these two, we're going to put them together because they add up to 1, sine squared and cosine squared of the same angle, in this case alpha. These two, we're going to put them together. Sine squared beta plus cosine squared beta, they also add up to 1. Okay, so on the left side, we are going to put these two together in a blue color. We're going to put these two together in a red color. And this one is negative 2. This one is also negative 2. We factor the negative 2 out. Cosine alpha, cosine beta, plus sine alpha, sine beta. Please understand these two will result in this. Now, let's go to the right-hand side. The right-hand side, this guy and this guy, both of them, this is sine squared of alpha minus beta. This is cosine squared of alpha minus beta. As long as the two angles are the same, you can put them together. Okay. So you get cosine squared of alpha minus beta plus sine squared of alpha minus beta. Then you have this one minus 2 cosine of alpha minus beta, and then plus 1. And let's see what happens. So again, it's pretty straightforward, everybody. Let's start with the left side. This is 1. This is 1. This is 1. This is 1. So on the left side, we have 1 and 1, 2 with this expression, minus 2 times cosine alpha, cosine beta, plus sine alpha, sine beta. On the right side, we have 1 and 1, 2, and then minus this expression. So clearly, the 2's can be canceled out from both sides. We can also divide both sides by negative 2. That's why we can cancel out the negative 2. Division by negative 2 now. So what is left must be equal. So this must be equal to this. Cosine of alpha, cosine of beta, plus sine of alpha, sine beta equals cosine of alpha minus beta, which is which one? This one. We just proved cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. The second part is very easy. In order to prove this one, you replace the beta here with a negative beta. Pay attention to what we are going to do. This is an easy proof now. Since we already proved this one, in order to go from negative beta to positive beta, if we replace this one with negative beta, remember this is what? Positive. And now we are going to apply this one. Cosine of alpha minus something. Imagine this is x. Imagine this is x. So cosine alpha, cosine x. Plus sine alpha, sine x. That's the meaning of it. Imagine this is x. So we have cosine alpha, cosine x or cosine of minus beta, plus sine alpha, sine x, that means sine of minus beta. As you know, so replace the beta with minus beta, okay? As you know, cosine is an even function. Cosine of minus beta is the same as cosine of beta. This is the same as cosine of beta. And as you know, sine is an odd function. So sine of minus beta is minus sine beta. And therefore, cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta, which is the first one. We proved both of them. You're not responsible for the proof, but if you can follow it, you're in good shape, everybody. Use sum and difference formulas to find exact values. We're going to find the exact value of cosine of 7 power 12. Now, if you have a hard time seeing that this is 3 power 12 plus 4 power 12, and the reason we do that because 3 power 12 is power 4, 4 power 12 is power 3, and both of them are common arcs, you can change it to degrees and then figure this out, okay? You can quickly do that. So remember, just multiplied by 180 over pi. So again, I write this for you just to remind you. Remember d over 180 r over pi, d is in degrees, r is in radians. So with that being the case, now we are going to follow the first formula. Cosine of alpha, cosine of beta, cosine of power 4, cosine of power 3, minus sine alpha, sine beta, minus sine of power 4, sine of power 3. And as I mentioned, they're all common arcs. Cosine of power 4 square root of 2 over 2. Cosine of power 3 is 1/2 minus of sine of power 4 square root of 2 over 2. Sine of power 3 square root of 3 over 2. I hope you realize the importance of knowing all those common arcs. So this one, the denominator is 4, so is this one. And the product of these two is square root of 2. The product of these two is square root of 6. So we get square root of 6. 2 minus square root of 6 over 4. Very straightforward, everybody. Use sum and difference formulas to find exact values. We are interested in finding cosine of 15 degrees. And clearly, one easy way you can say is cosine of 45 minus 30. Or even 60 minus 45 and work on it. You pick two angles that are common angles, arcs. Later on with the half angle, this is 30 over 2, you can go that route too. So now you are going to follow this formula, cosine alpha, cosine beta, plus sine alpha, sine beta. So cosine 45, cosine 30, plus sine 45, sine 30. So we just follow the formula. Again, common angle, we should know the answer. cosine is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Sine of 45 is square root of 2 over 2. And sine of 30 is 1/2. Again, each one, the denominator is 4 class. So the product, right? So you have to add up the numerator. So this gives you square root of 6. This gives you square root of 2. So square root of 6 plus square root of 2 equals 4. By the way, it's important to recognize it's pi over 12 in case you come across a radian format. It would be helpful to recognize that. All right, we already have those, and we are going to discuss those formulas. Okay. We are going to establish those later on. So let's look at cosine of power 2 minus theta, which is sine over theta, and sine of power 2 minus theta, that is cosine theta, and look at that from the point of view of graphing calculator, and also an analytic or algebraic method. We prove that, okay? Remember, they are considered co-functions, theta and power 2 minus theta. When two angles add up to 90 degrees or power 2, they are considered co-functions, and cosine is the same as sine, sine is the same as cosine, tangent is cotangent, and so forth. So basically, graphing calculator, y1 is cosine of power 2 minus x, and y2 is sine x, and you just see one graph. That is actually the proof from a calculator. However, the first one, we can use cosine of alpha minus beta. So we are going to go with the first one. I'm going to prove the first one. So according to this one, cosine of alpha minus beta, so this would be cosine of power 2 cosine theta plus sine of power 2 sine theta. And as you know, cosine of power 2 is 0, sine of power 2 is 1. This goes to 0, this goes to sine theta. We just proved cosine of power 2 minus theta is equal to sine theta. We proved the first one, everybody. Now, we want to prove the second one. To prove the second one, we are going to use the first one. And first, notice how we are going to do that. Power 2 minus power 2 plus theta. Please understand that this entire thing is theta. First, this thing is what? Just, I'm going to erase it, but what is this? Power 2 minus power 2 plus theta equals theta. So this is, both of them represent cosine theta. This is cosine theta, this is cosine theta. I want you to first and foremost recognize. Then if we let this one be x, okay, and use that one, we're going to use this formula. Let me erase my work so it becomes easy to see. So we're going to call this x. Imagine it's cosine of power 2 minus x instead of theta, minus x. Power 2 minus x. According to this, the answer is sine x. Power 2 minus x, that means sine x. And x is what? Power 2 minus theta. So sine of power 2 minus theta. Sine of power 2 minus theta. So we proved sine of power 2 minus theta is cosine theta. Let's rewrite it again. So sine of power 2 minus theta is cosine theta. And that is the second one. We just proved the second one. It's actually very simple. to the point that it could get confusing, okay? And I hope it's not confusing. I hope everybody is fine with that, but just in case, okay? All right, so again, it's pretty straightforward. We just wanted to prove those identities, and now we are ready to move on. All right, the sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. And of course, the cosine and these two from the previous page. So sine of alpha beta, in order to go with sine of alpha beta using what we have already proved, we have proved both cosines, cosine of alpha plus beta as well as cosine of alpha minus beta. So we want to use, if we want to go with this one, we want to use cosine of alpha plus beta. And to do so, we are going to go here and say cosine of power 2 minus theta is sine of theta. So sine of alpha plus beta, if you assume this is theta, everybody, if you assume this is theta, then it becomes cosine of power 2 minus theta. So one more time. Sine of alpha plus beta. Assume alpha plus beta is theta. So we can write it in this fashion. Cosine of power 2 minus theta. Cosine of power 2 minus theta, which is alpha plus beta. And now we are going to work on this and prove that sine of alpha plus beta is what you see. Okay. So I hope it's clear to everybody. And as I mentioned, it's very straightforward, everybody. We are going to write this power 2 minus alpha and then minus beta. And now we are going to use cosine of alpha minus beta. We're going to use this formula. So cosine of this, cosine of power 2 minus alpha times cosine beta plus sine alpha, that would be sine of this, according to this formula, power 2 minus alpha, sine beta. So I hope you can see that, everybody. So one more time. We are using cosine of alpha minus beta, which in this case, the alpha is has been replaced by power 2 minus alpha. Okay. All right, now we go to the top here and we recognize that cosine of power 2 minus alpha is what? Sine alpha. What about sine of power 2 minus alpha? Cosine of alpha. And therefore, sine alpha cosine beta plus cosine alpha sine beta, we proved that sine of alpha plus beta is sine of alpha cosine beta plus cosine alpha sine beta. We proved the first one. Now, in order to prove the second one, we do the same thing here and we replace beta with negative beta. So sine of alpha minus beta is the same as sine of alpha plus negative beta. That's the same thing. And so with that being the case, now we can use this formula. We're going to write sine alpha plus cosine of negative beta plus cosine alpha sine of negative beta. In other words, in this formula, class, in this formula, replace wherever you see beta, replace it with negative beta, okay? And so what happens, cosine is an even function. It's the same as cosine beta, but sine is not. So this one is the same as cosine beta, and this one is the same as negative sine beta. Therefore, this doesn't change sine alpha cosine beta, but this one becomes negative. And we write sine alpha cosine beta minus cosine alpha sine beta. So we prove the second one as well. Use the sum and difference formulas to find exact values. In this case, we are interested in finding sine of 19 pi over 12. We are looking for two common arcs. 19 is the sum of 16 and 3. So we can say 16 pi over 12 and 3 pi over 12. Why? Because this one is 4/3 pi and this one is pi over 4. Both of which are common arcs. So sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. So this is sine of 4 pi thirds cosine of pi over 4 plus cosine of 4 pi thirds sine of pi over 4. Now we are going to replace each one. Now remember, 4 pi thirds is important to recognize immediately that the reference arc is pi over 3. Which means what? Sine of 4 pi 3 is the same as sine of pi over 3, but could be positive, could be negative. You have to pay attention to the quadrant. Sine of pi over 3 is positive square root of 3 over 2. 4 pi thirds is in the third quadrant. As this one is in second quadrant. My apologies, third quadrant. I said it and I messed it up again. So in the third quadrant, sine is negative. Therefore, square root of 3 over 2 for this, minus square root of 3 over 2 for this. Pi over 4 cosine and sine, both of them are square root of 2 over 2. Cosine of 4 pi over 3, again, in the third quadrant, in fact, sine and cosine are both negative. So cosine of pi over 3 is positive 1/2, but cosine of 4 pi thirds is negative 1/2. So the reference arc is really helpful. So what do we have here? This, first of all, the product of these two and these two, the denominator is 4. So the denominator is 4. And this gives you minus square root of 6. This gives you minus square root of 2. So minus square root of 6 minus square root of 2 over 4. This is an exact answer. I can't emphasize this enough, everybody. We should pay attention to the exact answer. You should be able to do the exact answer as long as you know the common arcs. Exact answers, you don't need a calculator. And that's the idea. All right, let's repeat the concept of exact answer here. Use the sum and difference formulas. Find exact values, cosine 40, cosine 80 minus sine 40, sine 80. Cosine alpha, cosine beta minus sine alpha, sine beta. Assume this is alpha, this is beta. Alpha. So what are we looking at? Cosine of alpha plus beta, cosine of 40 plus 80. Which is cosine of 120 degrees. And remember, reference arc is 60 degrees. And cosine of 60 degrees is positive 1/2. In the second, and let me just write down this is, so this is in the second quadrant. Cosine is negative, so negative 1/2. Sine 80 cosine 20 minus cosine 80 sine 20. Again, let's call this alpha. Let's call this beta. So it's this one. Sine of alpha minus beta. 80 sine of 80 minus 20. Sine of 60, it's a common arc. You know it to be square root of 3/2. It's in the first quadrant. We continue finding exact values. So given sine alpha is 4/5 and alpha is between pi/2 and pi. Quadrant 2. Okay. And sine beta is -2/√5 or -2/5/5 if you rationalize it. And this angle is between, this is beta plus. Between pi and 3/2, which makes it the third quadrant. Okay, it's the third quadrant, everybody. Find the exact value of cosine alpha, cosine beta, cosine of alpha plus beta, sine of alpha plus beta. All right. Remember, we have sine alpha, we want to find cosine alpha. We have sine beta, we want to find cosine beta. And when we find those, then we use these formulas and we'll find the answer for cosine alpha plus beta and sine alpha plus beta. We don't have anything to worry about that. So what do we do? All right. There are two ways. I'm going to quickly remind you of both ways that we have done with circles as well as identities. So if you go with a circle, sine is 4/5. 4/5 is y over r. And we said it's the second quadrant. So y is positive and r is always positive. Okay, 5. It's in quadrant 2 as it was mentioned. Now x squared plus y squared equals r squared. That means x squared plus y squared is 25. Okay, x squared plus y squared is 25. It's x comma 4, right? So if you plug in, I hope you recognize the answer for x is plus minus 3, everybody, plus minus 3. In the second quadrant, x is negative. And cosine is x over r, -3/5. Remember, in quadrant 2, cosine is negative. On the other hand, we could go with the identity plus minus the square root of 1 minus sine squared. So plus minus 1 minus, we're going to square this. And as you know, this is 16/25. 1 minus that is 9/25, comes out as 3/5. Plus minus 3/5. Quadrant 2, cosine is -3/5. So you have a choice of going with the circles, okay? You have a choice to go with the identities. Either one. If you go with the circle, you know what happens to x. If you go with the identities, quadrant 2 tells you that it must be negative. So we, from sine alpha, we found cosine alpha. Now let's go and use sine beta to get to cosine beta. And so sine is given as negative 2 squared of 5 over 5, and beta is between pi and 3 pi over 2, which gives us what? The third quadrant. It gives us the third quadrant, everybody. Let's do one way, okay? Instead of doing both ways, let's do it with identities. Cosine is plus 1 is the square root of 1 minus sine squared beta. So it's 1 minus u squared this, okay? And it may be easier to square this one. It doesn't matter. You get 4 over 5. Let me just do that. It's easier to do that one. Let me see what color I want to use. So this becomes 4 over 5. 1 minus that is 1 over 5. So plus minus the square root of 1 over 5. This is under the radical. You take it out, becomes plus minus 1 over square root of 5. I hope you have no problem with algebra, everybody. So under the radical, we have 1 over 5 plus minus square root of 1 over 5 is plus minus 1 over square root of 5. And so we choose negative because in this quadrant, quadrant 3, cosine is negative. So the answer is negative 1 over square root of 5. And if you rationalize, you get this. So the idea was that to get those two first, and this becomes easy. Cosine of alpha plus beta. It's cosine alpha, cosine beta minus sine alpha, sine beta. So let's write everything that we found in a table to make it easier to plug in. So we had sine alpha as 4 over 5. We found cosine alpha as negative 3 over 5. We had sine beta as negative 2 squared of 5 over 5, or negative 2 over squared of 5, makes no difference. And cosine beta, we found it to be negative square root of 5 over 5. And now let's plug it into a formula for this. Cosine alpha, cosine beta minus sine alpha, sine beta. And so we are going to multiply cosine alpha. We're going to multiply these two minus, we are going to multiply these two. So I hope you can see that. Let me see, what color do you want to use? I hope you see that you have minus. Actually, minus and minus becomes plus because this is negative, so is this one. So plus 3 square root of 5 over 25. The other one plus 4 times 2, 8 square root of 5 over 25. And 8 and 3, 11 square root of 5 over 25. What is sine of alpha plus beta? Sine alpha cosine beta plus cosine alpha sine beta. So sine alpha 4 over 5 times cosine beta minus square root of 5 over 5 plus cosine alpha negative 3 over 5 times sine beta minus 2 square root of 5 over 5. So this one gives us negative 4 square root of 5 over 25. The second one gives us plus 6 square root of 5 over the same denominator. So negative 4 and 6, they add up to positive 2 square root of 5 over 25. So that's pretty straightforward. I hope everybody's okay with that. Cosine of power 2 plus theta equals negative sine theta. Establish identity. We want to prove that. As always, we start with the more complicated side. So we start with the left-hand side. And we are going to distribute according to the formula for cosine alpha plus beta. So this becomes cosine of power 2 cosine theta minus sine power 2 sine theta according to this one. Cosine of power 2 is 0. Sine of power 2 is 1. So this goes to 0 and we get minus sine theta. And believe it or not, that's the proof, everybody. So it's pretty straightforward. We're going to do the same thing here. We are going to use the same identity, cosine of alpha plus beta, same identity. So the left-hand side is more complicated. So cosine pi cosine theta minus sine pi sine theta. That's what we are going to use. Okay, so again, pretty straightforward. What do we know about cosine pi? It's -1. What do we know about sine pi? It's 0. Therefore, this goes to 0. You end up with negative cosine theta, and that's a proof. So one more time. Cosine of power 2 plus theta is negative sine theta. Therefore, cosine of pi plus theta is minus cosine theta. Sum and difference formulas for tangent. We have them for sine and cosine. We want to prove tan of alpha plus theta is tan alpha plus tan beta over 1 minus tan alpha tan beta. We want to prove this one first. And remember, basically, tangent is what? Sine over cosine. So sine of alpha plus beta over cosine of alpha plus beta. That's all. And we know sine of alpha plus beta, and we know cosine of alpha plus beta. Just use those. So this is the proof for tangent. Now, what we want to do is, when we look at this one, we notice this is 1. Pay attention to the process. We notice, what color do I want to use? We notice this number is 1. So think about how you can make this one 1. Divide by itself. Okay, everybody? If we divide this one by itself, it becomes 1. So divide everything by cosine alpha, cosine beta. Divide everything by cosine alpha, cosine beta. Make up 2 fractions for the numerator, 2 fractions for the denominator. First and foremost, notice this is 1. So this is 1 because the top and the bottom are identical. Then notice this one. Sine alpha over cosine alpha is tan alpha. Sine beta over cosine beta is tan beta. Denominator, sine alpha over cosine alpha is tangent alpha. Sine beta over cosine beta is tangent beta. And that's the proof. Now, all you have to do, use this formula. If you replace the beta with minus beta, you can prove this one. I'm going to leave it for you as we did it before. We did it for sine and cosine. So into this formula, if you replace the beta with negative, that means this is tan of minus beta. That means this is tan of minus beta. And I hope you know tangent is odd. So this becomes minus tangent. This becomes minus, with minus becomes plus. Give it a shot. It shouldn't take long. So you can easily prove that. Tan of 2 pi minus theta is minus tan theta. And to prove that, we are going to go with tan of alpha minus beta. Alpha is 2 pi and beta is theta. So the left-hand side, we're going to say tan of alpha minus tan of beta. So tan of 2 pi minus tan of theta over 1 plus tan of alpha or 2 pi tan of beta or theta. As you know, tan of 2 pi is 0. So replace that one with 0. That's all you have to do. And so when you do that, what happens? This thing goes to 0. The numerator is negative tangent. The denominator is positive 1. The result is negative tan theta. So that's a proof. By the way, remember, tangent, just like the rest of the trigonometric functions, is periodic with the period of pi. So 2 pi would be a period, except this is negative theta. That's the thing, okay? If it were positive theta, the answer would be tan theta. Cosine of alpha minus beta over sine of alpha sine beta is cotangent alpha cotangent beta plus 1. We can start from one side. So for example, let's start from the left-hand side. Left-hand side, there's nothing we can do for the bottom. Cosine of alpha minus beta, we are going to use cosine of alpha minus beta, which is cosine alpha cosine beta plus sine alpha sine beta. And I hope you recognize that you can make up two fractions. This is one. This is one fraction. This is the second fraction. So obviously this is 1. Cosine alpha over sine alpha is cotangent alpha. Cosine beta over sine beta is cotangent beta. And we're done. We just proved that. Tan of theta plus pi over 2 is minus cotangent theta. Plus, if it were minus pi over 2 would be equal to cotangent theta because they're co-functions. But because it's plus, that's not the case. Let's show that by looking at the left-hand side. So tan of alpha plus beta, okay. The fastest and easiest way would be to write it as sine over cosine, okay. Sine over cosine. So sine of theta plus pi over 2 over cosine of theta plus pi over 2. And now expand. Sine of theta plus pi over 2, you write down sine theta cosine pi over 2 plus cosine theta sine pi over 2. So this one, we are going to expand it, obviously using sine of alpha plus beta. And the bottom one, we are going to expand it using cosine of alpha plus beta, which makes it cosine theta cosine pi over 2 minus sine theta sine pi over 2. And all we have to do, replace the known values. Cosine of pi over 2, 0. Sine of pi over 2, 1. Same thing here, 0. Same thing here, 1. And so when we do that, here's what happens, everybody. So this is times 0, it's 0. This is times 0 is 0. So what you're looking at, the numerator is cosine theta and the denominator is negative sine theta. So that makes it negative cotangent theta. So it's easy to see, everybody. We want to establish this identity, everybody. Cosine of alpha plus beta over cosine of alpha minus beta is 1 minus tan alpha tan beta over 1 plus tan alpha tan beta. We start from one side. The left side can be expanded, okay? So because cosine of alpha plus beta, we can use this one, cosine alpha cosine beta minus sine alpha sine beta. And for cosine of alpha minus beta, we can use this one, cosine alpha cosine beta plus sine alpha sine beta. So that makes it feasible to work with. Now, we want to make this look like the right side, and we notice that this is 1, this is 1. And if we divide the top and the bottom by this piece, this becomes 1, this becomes 1, and let's see what happens to the rest of it. So we are going to divide everything by cosine alpha, cosine beta. Again, because we notice this is 1. That's how you get the trick. And so obviously this is 1, this is 1. And then you look at this one, you say sine alpha over cosine alpha. This one is sine beta over cosine beta. If we separate them in this manner, we can read that this is tangent alpha, tangent beta, same thing here. And we just prove this one. By the way, the second method you could use, you can start from the right-hand side, change the tangent to sine over cosine. In both cases, this is sine alpha over cosine alpha. This is sine beta over cosine beta, and go this route. In other words, if you from here you go to here to here to here, you can see the reverse process. It can be done that way also. Find the exact value, and that is always the case. When it's possible to find the exact value, we're not going to use a calculator class, and therefore we use our techniques that we have learned here. All right, so here's what's happening. Cosine of cosine inverse of 2/3 plus sine inverse of negative 3/4. Remember, each one of these represents an arc. So let's say this is alpha, let's say this is beta. What does it mean? This means cosine alpha is 2/3. This means sine beta is negative 3/4. So cosine alpha is 2/3 according to this. And of course, remember, cosine, when you look at the inverse, okay, cosine covers the first and the second quadrant, right? So this is in the first quadrant because it's positive. In the second quadrant, cosine is negative. On the other hand, sine inverse covers the fourth quadrant and the first quadrant, and because it's negative, it's in the fourth quadrant. So sine of beta is negative 3/4, and it's in the fourth quadrant. So this means, everybody, quadrant 1, quadrant 4, okay? The reason we need that, because we want to know what happens with all the trigonometric functions and their sign. So we're going to go with the identity, sine squared plus cosine squared equals 1 in both cases. And in this case, sine alpha is plus minus the square root of 1 minus cosine squared of alpha. And we know we are in the first quadrant. In the first quadrant, everything is positive. Okay, so just plus 1 minus. Now we know this to be 2/3. So 2/3 to the power of 2 makes it 4/9. 1 minus that is 5/9. So square root of 5 over 9 or square root of 5/3. And we're going to use the same thing here. Sine squared plus cosine squared is 1, and cosine is plus minus the square root of 1 minus sine squared, just like that. However, in quadrant 4, cosine is positive. Okay, it's important to know. Cosine is positive in the 4th quadrant, right? Everybody remembers that? All right, so therefore, plus square root of 1 minus sine squared beta. So this one to the power of 2, and this is 9 over 16, and 1 minus that is 7 over 16, and it's square root of 7 over 4. So we want cosine of alpha plus beta. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. So please understand, this was alpha, this was beta. Cosine alpha cosine beta. Cosine alpha is 2/3. Cosine beta is square root of 7 over 4 minus sine alpha is square root of 5 over 3. Sine beta was given as negative 3/4. Okay. And again, the summary of the sine and cosine, I put them here. That makes it easier to deal with everybody. And now we're going to plug in. So clearly the denominator is 3 times 4, 12 for both cases. So this gives us 2 square root of 7. This gives us plus, because negative and negative is plus 3 square root of 5. So 2 square root of 7 plus 3 square root of 5 over 3 times 4, or 12. Let me quickly look at one more example, just in case. Secant of alpha minus beta is secant alpha secant beta over 1 plus tan alpha tan beta. And we can actually look at both methods, going from left to right and right to left. So from the left-hand side, we want secant of alpha minus beta. And we know secant is 1 over cosine. So 1 over cosine alpha minus beta. Okay. Cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. So we are looking at the left-hand side. What do we do next? We notice this is 1. So somehow we want this one to be 1. Take a look. If this was 1, that would be good. So how do you make this 1? If you divide by. So you can't just divide this one by, you have to divide everything by that. Let's do that. So again, how do you know this is the method? Look at what you are trying to establish. You are trying to get 1. And so numerator make up 2 fractions because you want to get there. So 1 over cosine, 1 over cosine, 1 over cosine alpha times 1 over cosine beta. And this one, 2 fractions. This part divided by this part divided by that. Okay. So that's what we did. Now, 1 over cosine alpha, secant alpha. 1 over cosine beta, secant beta. These two are identical. You really don't have to do anything. This is 1. Sine alpha over cosine alpha. Tan alpha. Sine beta over cosine beta. Tan beta. So we just proved it. So we proved that secant alpha minus beta is now this one, which is secant alpha, secant beta over 1 plus tan alpha tan beta. We just proved that. We could use the right-hand side. This would be a second method. I just want to show you sometimes, because the right side is pretty complicated too. And so what we do, we write the right-hand side, and secant is 1 over cosine. Secant is 1 over cosine. Tangent is sine over cosine. Tangent is sine over cosine accordingly. Well, the concept of a common denominator for the bottom says 1 is the same as cosine alpha cosine beta over cosine alpha cosine beta. So I can replace these with this. And now if I do that, then the top and the bottom have cosine alpha cosine beta as a denominator. And remember, you have a complex fraction, and a complex fraction that has identical denominators. You can cross them because the product of these two go to the top, the product of these two go to the bottom. Remember that? So I want to quickly show you here an A over B divided by C over D. You put A over D at top, the extremes, and then BC, the means at the bottom. That's exactly what happens. So that's why they get canceled out. Let me clean up my work and do it again with a different color this time. So these two cancel each other. 1 over cosine alpha cosine beta plus sine alpha sine beta. And this one, you know, it's cosine of alpha minus beta. And 1 over cosine of alpha minus beta is equal to secant of alpha minus beta. And that's the proof. So you can go either way, from left to right or right to left.